Good morning and welcome back. Today we're going to investigate a few more graphs. So yesterday we looked at circles and lines. Today we're going to see what if instead it's like r equals 4 plus 4 cosine theta, or something like 5 plus 2 sine theta, or sometimes it might have a negative there. So we're going to look at three examples. Once again, we're going to use charts to help us, and we're going to identify what these shapes are, because we're going to get some that aren't circles, shapes you haven't seen before. So once again, when we're dealing with cosine, we get to choose what values we use. Okay, and we can, let's see, I'll open up our unit square or circle. Oops, I almost said unit square. So back, not on that, chapter 7. If we find our unit circle, we want to say what values are nice. Okay, and when I say nice, maybe not nice what you think of, but nicer. So since we're dealing with cosine on this first example, cosine theta, okay, we look here, cosine will be nice here at 0. Here there's a square root, again at pi over 3. Here it's a 0, so that's nice. Here at 2 pi over 3, square root. So anytime it's got a 3 on the bottom or at one of these 4 spots on the axes. Okay, so for theta, I'm going to use 0, pi over 3, pi over 2, 2 pi over 3, pi, okay, then 4 pi over 3, 3 pi over 2, and 5 pi over 3. So once again, these are the values I'm choosing to use because when I find the cosine of 0, I get 1. That's nice. When I find the cosine of pi over 3, I get 1/2. That's nice to deal with. Okay? So we know it's going to be 4 plus 4 times 1 in this case, because it's cosine of 0 is 1. 4 times 1 is 4, plus 4, that'll give us 8. So 0 and a radius of 8, so out 8, that'll be right here. Okay, our next one. 4 plus 4 times cosine of pi over 3 is 1/2. 4 times 1/2 is 2. 2 plus 4 gives us 6. So pi over 3 comes all the way around to here, and it's out 6. Our next one, pi over 2. It's going to be 4 plus 4 times 0 in this case. 4 times 0 is 0. 0 plus 4 gives us 4. So at pi over 2, up 1, 2, 3, 4, right there. Okay, our next one, 2 pi over 3, 4 plus, I'm not sure how I'm getting this, cosine. So it's 4 times the cosine of 2 pi over 3. So we go over here, cosine 2 pi over 3, cosine's negative 1/2. Okay, so 4 times negative 1/2 is negative 2, plus the 4 gives us 2. Okay, our next one, pi. For pi, we're just going to take 4 plus 4 times, it'll be negative 1. So that will cancel out to 0. Oh, I forgot I'm supposed to be graphing these. So at 2 pi over 3, let's see, it's at 2. At pi, it's going to be at 0 here. Okay, our next one, we'll do it again. 4 plus 4 times negative 1/2. So that's negative 2. Negative 2 plus 4 gives us 2. Okay, so if we go around to 4 pi over 3 and then down 2. And when I say down 2, I mean 2 towards it. Okay, so positive 2. Okay, our next one, 4 plus 4 times 0. So that's going to give us a 4. Then finally, 4 plus 4 times 1/2. Is that 5 pi over 3? It is 1/2 for cosine. And that will give me to 6. So 5 pi over 3, out 1, 2, 3, 4, 5, 6. Okay, so now, starting here, we can go around becomes there. And there's our shape. As you can see, it's not a circle. It's kind of got this hook. If you turn your head to the left, you might notice it kind of looks like a heart. Okay, the name of this is actually a cardioid. Okay, now if you have any experience with the medical field, you might recognize that. It kind of sounds like cardiovascular, right? The Greek word of heart, the cardioid. So this is kind of comes from that Greek word for heart. Okay, it's up to you if you write that or not. That's just a fun fact. But cardioid, that is the name of this shape. As you can see, it's kind of got this hook in it. This chunk kind of looks like a heart. Okay, so that's one of our three shapes that we're going to look at today. Now the next one, and tomorrow we'll examine why these are different. So the next one, 5 plus 2 sine of theta. Okay, so we're going to do the same thing. This time we're dealing with theta of sine. So since we're doing sine, we want to use values that are nice for sine. So pi over 6 is a nice value for sine, because for pi over 6, it has 1/2. Pi over 4, not nice, square root. Okay, pi over 2 and 3 pi over 2 and pi and 0, those are always nice. Once again, the over 3, over 4, those aren't nice. Over 6, we want to do the ones over 6. Okay. And so we're going to solve these and graph it, and we'll see what shape we have. Okay, so if we look, on this one it'll be 5 plus 2 times the sine of theta. So sine of 0 is 0. So 2 times 0 is 0 plus 5 gives us 5. So at 0, out 1, 2, 3, 4, 5. Okay, our next one. 5 plus 2 times 1/2. 2 times 1/2 is 1, so that'll be 6. So we go around to pi over 6 and then out to the point 6, radius of 6. Okay, our next one, 5 plus 2 times 1. 2 times 1 is 2, plus 5 gives us a 7. All right, next one, 5 plus 2 times 0. No, not 0. I made a mistake. At 5 pi over 6, it should be 1/2. If you're not sure why, at 5 pi over 6, right here, the sign is 1/2. I got ahead of myself. So 2 times 1/2 is 1 once again, times plus 5 gives us 6. Okay, our next one, 5 plus 2, here's where we have 0, and we get a 5. All right, at 7 pi over 6, 2 times negative 1/2. So it'll be a negative 1, take us down to 4. At 3 pi over 2, it'd be a negative 1. So negative 2 plus 5 gives us 3. And the final one, once again, a negative 1/2, so that will take us to 4 again. So I need to plot those last few on there. So 4. 3, and 4. Okay, now when we plot this, it kind of looks like a circle, but as you can hopefully tell, it's kind of flat on the bottom. Okay, so it's flatter on the bottom. It doesn't have that curve, and maybe it's not perfect. Here's what it was supposed to look like. If we look right here, something kind of like this. It's supposed to kind of come up a little bit. So let me maybe draw that again on the bottom. Let's see. It needs to come up a little bit. Okay, so it's going to come around and come up and around like such. Okay, so it's not a perfect circle, but it is close. Okay, So, and this one is called our limacin. Okay, so Limacon, limacin. It's actually kind of French. It's got like that C there, limacin. Okay, and this kind of looks like a snail maybe to you. Hopefully, it comes from the Latin word for snail. And I know my picture is not perfect, but that's what we got. Okay, so we're just about done. We got one more to draw for us here. And this final one, once again, we're back to sine. So we're going to plug the same values in because they are nice for sine. So 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6. So we plug those values in. 2 minus 4 times 0. That'll give us 2. Okay. So now for the next one, once again, whatever sine of theta is, so sine of pi over 6 is 1/2. So 2 minus 4 times 1/2. That's going to be -2. 2 minus 2 is 0. 2 minus 4 times 1. So -4 times 1 is -4. 2 minus 4 is -2. We'll graph all these at the end in just a second. Once again, 4 times 1/2. So it'll be -2. We'll get a 0 again. 2 minus 4 times 0 is going to be a 2. Our next one, 2 minus 4 times -1/2. So that'll be +2 plus 2 gives us 4. 2 minus 4 times -1 gives us 4 plus 2 is 6. And 2 minus 4 times -1/2, that'll give us a 2. So 2 plus 2 is 4. All right. So 0, radius of 2 comes out here to 2. The next one, pi over 6 is at 0, so that'll be right in the middle. Next one, pi over 2, so up here at the top, but it's -2, so it drops down 2. So right here. Okay, our next one, 5 pi over 6, comes all the way around, but it's at 0 again. We already got that point. And pi is once again at 2. Our next one, 7 pi over 6 is at 4 out here. And 3 pi over 2 is at 6. And 11 pi over 6 is once again at 4. So this one looks a little goofy. It's like, how do we draw this shape? So if we start here and we draw it, and in the middle there's like this loop-de-loop, and then it goes the other way. And this is going to be the same shape as we had. This is once again a limacin, except limacin with loop. Okay? So limacin with loop is what we call it. As you can see, it's like the last one, except there's a loop in here. So that is all I have for you. If you have any questions, please reach out. Finish up the delta math from yesterday, get caught up, and then tomorrow we'll learn some more shapes. Hope you guys have a great day.